Boom. Alright, ladies and gentlemen, welcome to Jellyben Schools. In the last video, we were looking at the various ways on how to, not really the various ways, but the way you can actually design a welding machine by the use of transformers from a microwave. Two basic transformers from a microwave to be able to achieve a welding machine. So in the part one of that video, we were able to see how to, prepare the transformer for the winding process, okay, by removing the secondary winding and various things required. Then the second part of the video, which is the part 2, if you have not watched those videos, I would advise you go watch them because there are a lot of things you can learn from them. The second part of the video was the winding process, okay, and at the end of that video we were able to see how we could get to 27 volts, which is not sufficient enough for welding, but that is the voltage at which we got to because of the number of windings that we had. So in this video, we are going to complete the winding that is required for continuous welding, which is a minimum of 30 volts or 40 volts if you can, but 30 is just okay for you to continuously weld without issue. So we are going to add more winding, more turns in the secondary winding so that we can achieve that voltage. And then we are going to couple everything that has to do with the welding machine and then get it welded. So let's get started. So very firstly, this is the transformer. Let me adjust my camera. All right. So this is the transformer here. There are two transformers. I've already done the looping in the former video. You can watch that on the playlist. Just go to my playlist and you will see the videos I have made on this part. So these transformers have been looped in what we call a series arrangement. So each of these transformers are likely going to perform the function of a unit transformer because the cable coming through here has been looped into several turns, then continue with this wire into several turns in this one as well, and then I'll put in from here. So, but from what we have noticed in the last video, we were not able to achieve up to 30 volts. So in this video, we are going to wind. I'm using a black cable now because my red cable got finished. So we're going to use this cable to have more loops so as to achieve 30 volts as the case may be. So let's just kick that off. Alright, so right away we are going to start looping this one for more turns. So you have to be patient while doing this because it's going to take quite a lot of your time. This winding stage is the most tedious part of the process. Pretty tight. Perfect. So at this point, we have succeeded in adding some loops. You can count that. You have 1, 2, 3, 4, 5 from the back, and same thing here. You have 1, 2, 3, 4, 5 loops. So that's 5 complete loops. So the 5 loops we have now is enough to give us voltage that way, take us to 30 volts. So at this juncture, the looping is finally complete. So the next thing we are going to do right now is the coupling. We get the board. The first board you will need is a basic board like this, okay? So this will help us arrange stuff. All this stuff you see marked here where the positionings of the transformer. So I was making arrangement on how to position it properly so that it will maximize space and make things work accurately. So basically, these two transformers will sit here, something like this. This will be at the front, this will be at the back, and they will sit in such a way that they face each other this way. This is the better way, this method. This method looks okay, but I'm wondering if it will maximize space for me. Something like this, is it okay? It's a little bit questionable because we may not have enough space to do our jobs better. So, but it seems reassuring. But by the time you put your fans will be blowing in the wrong direction. So fans will not be blowing here. The fans have to blow the coils and not the side of the core. So it's best we take it something like this. Perfect, something like this. So with this, you have the total setup like this. So this can be the front and this one can be at the back, and you put them side by side like this. So these are going to be two transformers functioning as one. Of course, this is a series looping of the coils, and the transformers are going to be connected in parallel. And the reason for parallel connection is so that they can function together as one and give out the output voltage generated from the two of them put together. So on that note, the next thing to do is to start the connection proper. So at this point, it's time to loop the transformers together. In other words, we're going to connect the transformers in parallel, okay? So trying to do that now, first thing is to connect this one to this terminal, and this other one here. The second one to this terminal. then the last one here. Perfect. So now they are in parallel. So these two outputs will be going straight to the voltage regulator. Yeah, that will regulate the amount of voltage that will be entering these two transformers. So at this point, I'm taking these two outputs to connect them somewhere here. Alright, so let's get started. Now, this is the voltage regulator, okay? So the function of this guy is to actually regulate the amount of voltage that will be entering your transformer. You can increase the voltage to maximum capacity to about 220 volts, 230 volts. You can as well reduce the voltage to as low as 60 volts. So it's a voltage regulator, and it's very, very important for the process. While this you see here is simply a voltmeter, okay? So the essence of this voltmeter is to take the reading of the voltage that is entering, and as well the voltage that is being used. That's what you use this for, right? So at this point, let's get the voltmeter into place. Boom. So at this point, we are going to control the main switch. Yeah, the function of this switch is to control the shutting down of the whole system and the putting on of the whole system. So if you check, it has 4 terminals. The first 2 terminals at the bottom will be receiving power from your AC source. That's your 220 volts, and then to output it here to be controlled by 1, 2, 1, 2, right? So now what is coming out of here, one will be going straight to your transformer, while the other will go straight to your voltage regulator, okay? Now what is going through the voltage regulator as it's coming out is entering the second leg of your transformer, and by so doing, the power that is coming from here first of all goes through your voltage regulator. This is your voltage regulator. So it first of all goes through this voltage regulator. This voltage regulator will read the voltage that is entering the welding machine and can be adjusted through this knob here, okay? So you can just rotate this knob and it adjusts the voltage that will enter the two transformers at the end of the day to output whatsoever you want to weld with at that particular instant time. So basically that is that. And then also, just as introduced before, this voltmeter will be very pertinent. This voltmeter will just output the readings of the regulator on application. So this voltmeter is a digital one. If you check there, it's written, it's calibrated there to 20 volts, and this is 500 watts. Hope you can see that, but if you cannot see, there's no problem. So basically, this is a voltmeter. So at this point, we're going to connect this right away, and then get this connected as well, and see how the process continues to the end. So everything about the face is almost ready. So this is the outlook of the front view, okay? Your edge, your welding handle, your switch, your voltmeter, your voltage regulator, and your light indicator. So this is how everything looks still sophisticated from within. At this point, I have to put all the wires together and get the material tested. So this is the output. Ladies and gentlemen, this is a welding machine designed from 2 transformers that you can find in a microwave. Alright, let's get the job continued. Alright, so this is a copy of the dashboard. Sorry about that. So this is the dashboard of the welding machine, and this is the connection just at the back. So I'm going to explain briefly how every connection here works together to achieve the aim of the welding machine. First, we start with the input terminal. Okay, this is a switch. Here's a switch. You see that at the back here. So this is the switch. So what this switch does is to off and on the welding machine. Okay, so ideally, if you put on the welding machine, your indicator light will show, the current voltage in the welding machine will show, then this knob is going to be used to regulate the amount of voltage entering and leaving the transformers. Okay, and then what you have here are your output terminals for the earth, or let me say the red one is for the handle, while this is for the earth. Okay, so now how are they interrelated with each other electrically? First, input current 220 volts come through here, and then the 220 volts when switched on will travel through this wire and then get into the voltage regulator. Okay, so the voltage regulator in turn will increase or decrease depending on how you turn your knob, and then reduce the voltage and will send the output through this yellow current, through this yellow wire. Then the yellow wire will take it straight through this white wire to your transformer. Okay, then of course you have two transformers. We have two transformers, each of them will be connected in parallel to each other. Okay, so that they both function as one. And then this is for one of the legs of the input current. Now the input voltage also on the other leg will go straight to the other transformer, and that is going to be this red wire here. But before then, it will pass through the voltmeter. Yeah, this red stuff you see here, this is the voltmeter. Okay, it will display the amount of voltage either entering or leaving the transformers, as the case may be. Then the indicator light as well will tap from the two legs to, you know, make you inform that there is high voltage or there is power in the welding machine. Boom. All right, just a quick test to be sure that the connection we have here is in copacetic order. Okay, so first, this is my switch, my earth, my handle, my voltmeter, my regulator, and my light indicator. So now I got it connected to a power source, put it on, and then coming over here, I have to switch it on from here. Boom. So now it is on. The current voltage is at 198,200 volt. Okay, so this is actually a generator I'm using, so the voltage is not very high, and the indicator light is on here. So now I can regulate this voltage here if I reduce the voltage to any volt of my choice, and that is what it's going to be outputting. So let me take it to the barest minimum. The minimum voltage here is 70 volts. Okay, so I can operate at 70 volts. I can take it to any voltage at all that deems me fit. Now it's at 180, and if I take it to the maximum, it will be showing 200 plus. So now it's at 200 volts, and this design, this setup is in copacetic order, and we can start decoupling. Alright, so now we have to test the fans to be sure that they are in order as well. So positive, negative, the wires are connected already, and you flow down to the power source. Good. So the two fans are blowing and just doing very well. So at this point, we got to couple everything.